Hello, in this video I'm going to be solving some problems on first order homogeneous ordinary differential equation. So let's begin with problem number 1. Now, first order homogeneous differential equations look like this. As you notice, all the terms have the same degree or the same dimensions. In this case, x has a degree of 1, y has a degree of 1, so the total degree is 2. Here x has a degree of 2, y has a degree of 2. So you notice all the terms have the same degree. That is what it means for a first order differential equation to be homogeneous. Alright, so let's go ahead and solve this equation. Well, to solve this equation, we are going to make use of the substitution y to be equal to ux, where u is a function of x, so that means dy dx is going to be the same as if we apply product rule here. I keep u constant, the derivative of x with respect to x is 1, okay, there we go, plus I keep x constant, the derivative of u with respect to x, there we go. So I'm going to substitute, instead of dy dx, I'm going to substitute this. Then also another thing, I'll have to rewrite this equation in a better way. So let me do this. I'm going to divide the whole equation. So I'm going to divide the whole equation. In this case, if I divide by, let's divide by x squared. I guess that's going to be a little useful. If we divide this equation by x squared, then we'll have y over x. So we have y over x dy dx equals, that's 1, and then this is y over x squared. Notice from here that y over x is actually u. So we have u, and instead of dy dx, I'm going to write this. That's u plus x du dx equals 1 plus u squared. Okay, so I have changed the variable completely from y to u, and now I have a differential equation in u, and perhaps this is easier to solve. Let's see. This is u squared plus ux u dx equals 1 plus u squared. So this u squared and this u squared cancel out, and we have x du dx equals 1. Oh, this is not x, it's ux. Okay, so this is a simpler differential equation where we can separate variables. Okay, let's just create more space here. Right. So what we have here, if we separate variables, okay, there we go. In this case, we'll have du, okay, u du equals dx right by x, and if I take integrals on both sides, so the integral of u du equals the integral of 1 over x dx. That's what we'll have. This is u squared over 2. On the other side, we have natural log of x plus a constant. Okay, so I can write this c as natural log of k. Let's make that better. Natural log of k. So I write this as u squared over 2 equals natural log of kx. Okay, so k is also another constant, so this is totally fine. And so u is y over x, so I substitute back there, so I'll have y squared over 2x squared equals natural log of kx. And finally, my general solution is going to be y squared equals 2x squared natural log of kx. Okay, so here we go. This is the general solution to my differential equation. So this method of letting y to be equal to ux works for first order homogeneous differential equation, and it helps us to convert the first order homogeneous equation into an exact differential equation or a simpler differential equation that can be solved using a method of separating variables.